Welcome back to Civil Engineers YouTube channel. In this practical video, I will guide you for steel reinforcement details in the construction of this RCC slab, which you can see practically. If you see guys, at the distance of L by 4, already we provided crank bar to resist negative bending moment. Because this is two-way slab, therefore you can see bent up bar or crank bar on both directions. The length between two columns is here 16 feet at the distance of L by 4. We have crank bar, not extra steel rods. If you see guys, the main bars and distribution bar spacing is 6 by 6 inches, and we used here 12 millimeter die of steel rod. Guys, you can see this is crank bar section in this practical video, which are bent on 45 degree. The spacing is 6 by 6 inches. This is at the distance of L by 4 on the top of the floor beam, where we have negative bending moment. There we have more chances of cracks. To resist cracks, the extra steel rods or crank bar should be provided. As you can see in this practical video, this is crank bar, which is very economical to resist negative bending moment at the distance of L by 4. Especially we can provide where we have negative bending moment. At the middle we have positive bending moment. So there you can use also extra steel rods, but not an RCC slab, but you can provide it an RCC floor beam or plinth beam. Guys, you can see. In two-way slab, the crank bar should be provided on both direction, but in one-way slab, you can provide only in main side. Guys, you can see this is on 45 degree. On the other side, guys, they provided lapping length at the distance of L by 4, or you can see at the bottom section of this crank bar. So this is not good. Already they did. So this is a technical terms you should know about this, that the lapping should not be provided at the distance of L by 4. There we have more chances of cracks. To resist cracks, so provide extra steel rods or crank bar, but don't provide lapping length, which can weak the especially this zone where we have negative bending moment. This point is already weak compared to its middle. So therefore, if you provide the lapping length, so you are making more danger at steel structure. Guys, you can see this is at the distance of L by 4. On each side we have the length 5 feet crank bar. That's why, because here the span is 20 feet here. On the other side, that is 16 feet. So we have crank bar at the distance of 4 feet. If the span is more than 20 feet, so we are providing crank bar or extra steel rods at the distance of L by 3. Total length divided by 3, or if the span is up to 20 feet, so you can provide it at the distance of L by 4. Guys, you can see also the cantilever slab, or you can say the cantilever beam at the distance of, or the span is 7 feet. You can see already they did the steel reinforcement on the top of this, but they didn't provide any extra steel rods, especially in cantilever beam or slab. So these are very important to know before starting steel structure design. If you are going more than 2 stories, so you should hire the structure engineer to give you the structure design. Otherwise you will face more problems in steel structure, especially for any structure, if that is residential building or commercial building. So this is a short video to guide you for technical terms: crank bar, extra steel rods, lapping length, and RCC two-way slab. Thanks for watching. See you in next video. Goodbye.